All right, so I forgot to record when we started this today. On the first question here, the error analysis, what we decided was that he did not multiply either equation by anything to eliminate a term, neither the x nor the y term. He multiplied the second equation by 3, and he got 3x minus 6y equals 12. That's great, but now he can either add or subtract, but neither one is going to eliminate a term. So that was his error. All right, now we started looking at this one, and one of my fabulous students here said that we can't eliminate anything if we just multiply one equation by a number. Sort of true. We could multiply by a fraction, but I'm not going to go into that. So know that here. I'll give you a little way to think about it. Actually, if I multiplied this one here by negative 5/3, I would get a negative 5x. But let's not worry about fractions. It's easier just to multiply both equations by something. So what I do is I decide which variable I'm going to try to eliminate. We decided to eliminate an x term, the x's. So I look at the coefficient on this term, 5x, so the 5, and I take this whole equation and I multiply by 5. And I get the 15x minus 35y equals 80. Hopefully my multiplications are all correct there. And then I look at the coefficient on this one, the 3, and I decide, hey, I want to add these two equations, whatever they're going to be. I want to add them together. I could subtract them. If I were going to subtract them, I would just multiply by 3, not negative 3. But I take this 3 and I multiply this whole equation by negative 3 so I can get the negative 15x. And then negative 7y times negative 3 is positive 21y. And 16 times negative 3 is negative 48. And now I can take these two terms and I can add them together. And I get a 0x right there, but I don't need to include that. I get negative 14y equals 32. Do I have something wrong here? Well, no. Thank you. And it's also not 48. I was looking at the wrong one. Thank you, Jojo. So it's going to be positive 12y, yep, and then equals negative 57. Thank you, Jojo. Woo! That was a close call. We were really getting off on the wrong foot. So this is going to be a negative 23. Does that look right? Looks right to me. And then this is going to be a positive 23. Oh, yeah. That seems right now. Now we're going to divide by negative 23. 23. And we're going to get y is equal to negative 1. Questions on this, this step of multiplying the two equations? Any questions there? Or adding the two equations, or then solving for y? We're not done yet, but questions so far? Jojo, you caught my error, which means you get some candy at lunch today. Any kind of candy you want. Congratulations. All right, so now I'm going to substitute my negative 1 in for y, and I can do it in either one of these equations. It doesn't matter at all which one I choose. So I'm going to choose this one right here. So I have 3x minus 7 times y, well, y is negative 1 in this situation, and then equals 16. All right? That negative 7 times negative 1 is positive 7. Now continuing on to solve, we're going to need to subtract 7 from both sides. We get 3x equals 9. Dividing by 3 to isolate our x because we have 3 times x, and the inverse of multiplication is division. And we get x equals 3. So our solution is 3 and -1. And that's a xy coordinate point. It is the only xy pair that will make both of these equations true at the same time. Okay. It is also the point on the graph where if you graphed these two equations, it would show up as a point of intersection. And in a table, 3, -1 would be the only point that would be in both of these in the tables for both of them. So that is a solution to a system of equations. Questions so far? All right, whenever we have word problems, there are these steps. Read the problem more than once, define your variables, look at the question at the end of the problem for guidance. All right, so I'm going to just look at these steps kind of one at a time. Let's read the problem more than once. Russell Wilson and the Seattle Seahawks scored 55 points total at last night's game. They scored 7 points for each touchdown with the extra point, and 3 points for each field goal. Yep, that's how scoring in football works. The number of field goals scored was one more than twice the number of touchdowns scored. How many field goals did they score? How many touchdowns? All right, so we're going to read it again. Russell Wilson and the Seattle Seahawks scored 55 points total at last night's game. They scored 7 points for each touchdown with the extra point and 3 points for each field goal. The number of field goals scored was one more than twice the number of touchdowns scored. How many field goals did they score? How many touchdowns? We've read the problem twice. Define your variables. Look at the question at the end of the problem for guidance. So, how many field goals did they score? How many touchdowns? So, we're going to define our variables. I'm going to use G. Whoops. Let me use a smaller pen there. G for field goals, the number of field goals, let's say. The number of field goals. And I'm going to use a T for the number of touchdowns. And you should write that down in your problem. This is a step that I see a lot of students skip. And even as a teacher, I've been doing math a long time. I still write down the definitions for my variables when I'm defining those variables. I do that. It's a really important step. Next step, write a system of equations to represent the problem. All right, so we're going to need a couple equations here. I'm going to use this one first. Okay, so we're going to write an equation for that one. I think it's easier. The number of field goals scored was. So that was there often means equals. And it's true in this situation. The number of field goals equals one more than twice the number of touchdowns. One more than, that says +1. So I'm going to add 1 to something. And I'm adding it to twice the number of touchdowns. So that's 2t. Any questions on that one? All right. Next one. They scored 55 points total at last night's game. So on that one, the total often means equals. So 55 is the total number of points. They scored 7 points for each touchdown. So that means 7 times the number of touchdowns. This is how many points they scored on touchdowns. And then with the extra point, and 3 points for each field goal. So we're adding to that 3 points for each field goal. Questions about writing those two equations? The next step is to solve the system. So, oh, did I have F? I should have had G for field goals right here. Sorry about that. G. And now I notice that my G here is isolated. I love it when I have a variable isolated. That tells me that I can use substitution. So I can take all of this and I can substitute it into G in the other equation. So I have 55 is equal to 7t, so I'm just writing this equation out, plus 3g. So plus 3, and then g is equal to 2t plus 1. Questions about that substitution step? Hey, Savannah. Glad you're here. Good to see you. We're on page 10 in the packet, going through this practice problem. We're going to distribute the 3. So we get 55 is equal to 7t, and then 3 times 6t is, or times 2t rather, is plus 6t, and then 3 times 1 is 3. And I'm going to bring this up here for my next step, which is to combine my t terms. So I have 55 is equal to 7t plus 6t is 13t plus 3. Now there's nothing left for me to do on the left-hand side. There's just a number. And there's nothing left for me to do on the right-hand side. So now I need to start undoing operations. So I'm going to subtract the 3 from both sides to isolate my t term. So I have 52 is equal to 13t. Now I have 13 times t. To undo that multiplication, we use division. I divide by 13. 52 divided by 13 is 4. And on the right-hand side, we are just left with t. Questions about any of that? We're not done because we've only solved for one of the variables. We know that there were 4 touchdowns now. Now we need to find out how many field goals there were. So I'm going to use the top equation here. And I'm going to, so G is equal to 2 times the number of touchdowns, which is 4, plus 1. So here I have G is equal to 8. 2 times 4 is 8, plus 1. And G is equal to 9. So this tells me, next step here, do my answers make sense? If not, go back and look for mistakes. So one thing that I could do here now is to grab a calculator. So I'm going to bring in my calculator screen here. And I'm just going to verify. Is it true that if a team scored 4 touchdowns, 4 times 7, they would get 28 points on touchdowns? And if they scored 9 field goals, 9 times 3 is 27. Is 28 plus 27 55? It sure is. So it looks like we've done a pretty good job in our problem solving here. So the next step is answer the question in a complete sentence. So here we're going to say the team scored 9 field goals and 4 touchdowns. 55 points is pretty good, but 9 field goals and 4 touchdowns, I would be a little disappointed. But what do I know? All right, questions on any of that? Let's take a break, move our bodies for 1 minute, come back and get ready to go on the next problem. All right, example 2. We're going to read it twice. On opening day at Laurelhurst Theater for the movie IT, 40 adults and 26 kids attended, and the revenue for the showing was $486.70. The next day, 20 adults and 31 kids attended, and the revenue was $332.45. What was the price for an adult's ticket and the price for a child's ticket? Read it once, read it again. On opening day at Laurelhurst Theater for the movie IT, 40 adults and 26 kids attended, and the revenue for the showing was $486.70. The next day, 20 adults and 31 kids attended, and the revenue was $332.45. What was the price for an adult's ticket and the price for a child's ticket? All right, so we've read it twice to find the variables. Adult's ticket will be A, so that's the dollars for adult ticket. And then C will be the dollars for child ticket. That is step 2. Step 3, write a system of equations. I personally really like having highlighters when I'm doing systems of equations problems. So, one thing I see was 486.70. That's often an indicator of equals, and it's true here. So 40 adults and 26 kids. So 40 adults and 26 kids equals 486.70. Questions writing that system? The next day, 20 adults and 31 kids attended, and the revenue was $332.45. So here, 20 adults and 31 kids equals $332.45. So what process should we use to solve this system, do you think? Yeah, the elimination method. Yeah, great. So we're going to use the elimination method. And what I see is that if we multiply this equation by -2, we can get rid of the a's. So that's what I'm going to do. I'm going to multiply by -2 so I can get a -40. Now, if you can't do that, then this is the other thing I could do. So have a look and make sure you see this. I could multiply this equation by 20 and this equation by -40. So I could use these coefficients to multiply both equations, but I don't need to. So I'm going to just multiply the second equation there. So I'm going to switch these. This is something you can do if you have a digital work. It's nice. I'm going to take this and I'm going to multiply it by -2. Whoops, sorry. That's all crazy. Multiplying by -2. So I'll get -40a minus 62c is equal to, all right, so now I want to make sure that I get my multiplication here correct. So let's bring this over for a minute. So I want to multiply 332.45 times -2. Oh, I didn't, that kind of negative doesn't work. That's right. Let me fix that. There we go. So it's -664.90. So this is -664.90. All right, so now I'm going to take these two equations and I'm going to add them. I almost always do addition. You can use subtraction. If we hadn't multiplied by -2, if we had just multiplied by 2, then we could use subtraction. But I just normally do addition. That's just the way I do it. So we get 0 A's and we get negative, let's see, 26 plus a -62 looks like about 36 to me. So -36c is equal to, now -664.90 plus, so I'm taking that answer and I'm adding 486.70. And I should get -178.20. All right. Questions so far about any of my steps? Setting up the equation, multiplying, doing this first step of addition, and getting this. Anything so far? All right. Then the next step is to divide by -36 to isolate my C value. So I'll get C is equal to, so I'm going to divide by, I'm going to just write 36, but remember that it's a negative. So it's 4.95. A child's ticket is $4.95. Questions? All right, I'm going to take my original equation and I'm going to plug in 495 for C. So I have 20A plus 31 times 4.95 equals 332.45. And I could have used the other equation. It doesn't make any difference. So I'm going to take that 495 and multiply by 31. So I have a 20A plus 103.95. Whoa. Oh, thank you. Thank you, Naomi. All right, excellent. 31 times 4.95. Naomi, candy for you today, too. Good job. What kind of candy you gonna have at lunch? All right, all right. Personally, I'm a salted caramel guy. Mm-hmm. Yep, the gooey ones. Reese's. Yeah, yeah. I like some peanut butter with my chocolate. You know what I like even better than Reese's though is just taking like a nice dark chocolate bar and dipping it in some peanut butter myself. Give it a shot. All right, now we're going to subtract 153.45 from both sides to get the A value by itself. And we'll get, let's see, 153.45. So I'm going to say we're going to take our answer and we're going to make it a negative. So that previous value, 153.45, and we're going to add to that 332.45, and we'll get 179. So 20A equals 179. Now we're going to divide by 20 to isolate our A value, and we will get A is equal to 895. So our solution then is that an adult ticket, I'm going to use shorthand for ticket there, is 895, and a child ticket is 495. Hmm. All right. So let's um let's have a look. So you did. I'm gonna um copy this real quick. So you took this uh 40A plus 26C here, and so you put in 495 for the child's ticket, right? So you have 40A plus 26 times 495 is equal to 486.70. All right. So now the 26 times 495 is 128.70. We have 40A plus 128.70 is equal to 486.70. So I'm going to subtract 128.70, and I'll get 40A is equal to, yep, 358. Now we're going to divide that by 40, and we should get 895. Ah, well, it's good to see that it works both ways, right? Thanks, Jojo. Questions on any of that? I'm going to go through this one pretty quickly so we have time to finish here. At the homecoming dance, the school's photographer took pictures of couples. Crystal and Dan paid $3.25 for a wallet-sized photo and $10.50 for a portrait-sized photo, and spent a total of $61.50. They ordered a total of 10 photos. How many of each type of photo did they buy? At the homecoming dance, the school's photographer took pictures of couples. Crystal and Dan paid $3.25 for a wallet-sized photo and $10.50 for a portrait-sized photo, and spent a total of $61.50. They ordered a total of 10 photos. How many of each type of photo did they buy? So how many of each type of photo they bought means that what we're looking for is for the number of wallet-sized photos and the number of portrait sized photos. So now I'm going to write my system of equations. $3.25 for a wallet-sized photo, $10.50 for a portrait-sized photo, spent a total of $61.50. So here, I know that $3.25 times a wallet, that gives me the total amount spent on wallet-sized photos, plus $10.50 times the number of portrait photos, so this gives me the amount spent on portrait photos, is a total of $61.50. There is one of my equations. The other equation, total of 10 photos. So that tells me that the number of wallet-sized photos, W, plus the number of portrait-sized photos equals 10. So we can use elimination here, but we need to multiply something somewhere. I'm going to suggest that we let's multiply this equation by $10 or 10.5. So I'm going to switch the order here just because I like to do this thing where I take the top equation and I multiply it by something, and then I can just do them right in order there. It's handy. So we're multiplying here, and I'm going to multiply it by 10.5. So when I do that, I get 10.5 W plus 10.5 P equals, well, 10 times 10.5. Let's just make sure that we do that correctly. It's going to be 105. All right. Questions so far? Notice that now we need to subtract because we have two positives here. So we're going to subtract. So we're going to do 3.25 minus 10.5, and that will give us negative 7.25 W. This will make a 0. And then we do 61.5 minus 105. So that's going to equal negative 43.5. Now I can isolate the W by dividing by 7.25, or negative 7.25, excuse me. So I'm going to divide by negative 7.25, and I'll get 6. So W equals 6. Now here's something that's key. Notice that in some of the other problems, we've had decimals. Why would it not make sense for us to have like 6.5? Why wouldn't that make sense here? That's right. And if they charged me for half of a photo, like what, the top half of the photo, that would be weird charging me for that. I want the whole thing. All right. Now we're going to substitute. I picked the equation that looks easiest for substitution. That one looks easiest to me. So we have a 6 plus P equals 10. I'm going to subtract 6 from both sides, and I get P equals 4. So my solution, they bought 4 portraits and 6 wallets. Or, yeah, that's good enough. Questions? Give me some some feedback here. How are you guys doing on this? Have a look at this problem, and you're gonna do your best to answer this question. Make sure you follow those steps. Read the problem more than once, define your variables, look at the question at the end of the problem for guidance, write a system of equations to represent the problem, solve the system, ask yourself, do my answers make sense? If not, go back and look for mistakes. Answer the questions in a complete sentence. I'm going to give you about 7 minutes to work on this. 7 minutes starting now. If you're doing this at home on YouTube, you should pause your video and work until you're done and then start again. Okay, here we go. So on this problem, the math club, awesome, sold roses and tulips for Valentine's Day. The number of roses sold was 8 more than 4 times the number of tulips sold. Tulips sold for $2 each and roses for $5 each for a total of $414. How many roses were sold? All right, pretend we read that twice. Hopefully you did read it twice. I've defined my variables. It says how many roses were sold, but it's going to be helpful if I could do this 2 ways. We actually don't need to have both variables, and I'll show why in just a bit. All right, so it sure does make it easier, actually. So we have 2 equations here. Tulips sold for $2, so 2 times the number of tulips. And notice that when I use the variable t, I put this little hook on it at the bottom right here. But when I write my t's normally, I don't. That's how we can make sure that it doesn't look like an addition sign when we use t as a variable. So you might remember to do that. It's a good idea. And means plus, and roses sold for $5 each. So 5 times the number of roses. For a total, that's equals $414. I don't need those 2 decimal points there. So if you didn't include them, that's just fine. So the number of roses sold was 8 more. Oh, I guess I should have highlighted the number of roses sold. So the number of roses sold, that's R, that's equals 8 more than, so plus 8 more than 4 times the number of tulips sold. Any questions about those equations? All right, so now we're going to substitute this in for R right there. So we get 2t plus 5 times R. R is 4t plus 8, and that equals 414. I'm going kind of quickly because we don't have a ton of time left in class here. We have 2t plus 20t plus 40 equals 414. Now I can combine my t terms here to get 22t plus 40 equals 414. I'm going to subtract 40 from both sides. Whoops. And I'll put the result right up there. It is 22t equals 374. Hopefully that's what you got. Hopefully that's correct. If it's not correct, please do let me know. That's what I got. So now I'm going to divide both sides by 22, and I'll get t is equal to, so 374 divided by 22 is 17. And it makes sense that it's a whole number because it's that's the number of tulips sold. So now we need to figure out the number of roses sold. So I'm going to take this and I'm going to do R is equal to 4 times the number of tulips, which was 17, plus 8. 4 times 17 is, let's see, 2 times 17 is 34. So double that is 68. So R equals 68 plus 8. So R equals 76. So our answer, the number of roses sold was 76. Questions on that one? All right, let's go to the next one. Pause the video for until you try the problem, and then I'm going to go over it. I'm going to go over it in about 5 minutes. It's going to be a short time for you to work on it. As you can see, I've started the problem, and I've come up with the cost for a child's ticket is $49. And I did that, started getting going on that because of time here. Sorry about that. We are running short. We've had too much fun this period. So we have 2a plus 3 times c, and c is $49, equals 285. So that 3 times 49 is going to be, whoops, it's going to be 147. So we have 2a plus 147 is equal to 285. So we need to subtract 147. And we should get 2a is equal to, whoa. Is that right? Did I make an error here? Yeah, I must have made an error. Does anyone see where my error occurred? Right here. Yeah, so it's 285 minus 147. So it's 138. There we go. And then we need to divide by 2, and we get 69. So what we have is that a child ticket is $49 and adult ticket is $69. So the question is, how much would it cost to have 6 adults and 4 children? So 6 times 69 plus 4 times 49. So 6 times 69 plus 4 times 49 is $610. And that is the answer. And that's the end of our time together today. Oh, geez, I'm sorry you didn't see that. There you go. All right. So remember, we have, and you had that video yesterday that you should have done. Next Tuesday, you have the async review. Friday is the team test, and the following Tuesday, right before spring break, is the individual test.